In this review, we'll take a look at problems 419 and 420, and both of these concern the pigeonhole principle and the generalized pigeonhole principle. Find the minimum number of students that must be enrolled in a class to guarantee that at least 2 students have the same birthday. Well, there are 366 possible birthdays. Okay, so if I have one more person than possible birthdays, so if there are 367 students, so there's one more student than there is birthdays, then at least 2 must have the same birthday. By the pigeonhole principle. If there were only 366 students, then it would be possible for everybody to have birthdays on different days. But if there are 367 students, then you have to have at least 2 of them. 2 of these pigeons, the students, must share the same pigeonhole, and the pigeonholes are the birthdays. Okay, 420. Suppose that there are 11 students enrolled in the class. Explain that of these 11 students, there must be at least 3 freshmen, 3 sophomores, 3 juniors, or 3 seniors. So in this case, the pigeons are the students, then there's 11 of them, and the pigeonholes are the class rank, freshmen, sophomore, juniors, seniors. Now, the generalized pigeonhole principle says that if we compute the ceiling of 11, choose 4. Or sorry, not choose 4, 11 divided by 4. If we find that, that's a ceiling of 2.75, which is 3. So by the generalized pigeonhole principle, at least 3 students must be in the same class rank. If there are 11. The idea is that if there are only 8 students, then you could have 2 freshmen, 2 sophomores, 2 juniors, and 2 seniors. But if you have more than 8, then they have to have at least 3 in one of the class ranks. Part 2. Find the minimum number of students that need to be enrolled in the course to guarantee that there are either 6 freshmen, 6 sophomores, 6 juniors, or 6 seniors in that class. Okay, so for this one, the answer is going to be, I need to find the value of x so that the ceiling of x is equal to 6. Okay, so this is a kind of an unusual problem. If the problem was simply x over 4 equals 6, then clearly the answer is x equals to 24. However, we can actually go a little bit smaller than that. If I solve x of 4 equals 5, then I would get x equals 20. So it turns out the answer is the next number up from this, 21 over 4. So the answer is 21. The reason the answer is 21 is because if I take the ceiling of 21 over 4, that's the ceiling of 5.25, which is 6. And that's the number that's required in the problem. I need 6 students to appear in the same class. So the answer for this one is 21. If I have 21 students, that's the minimum number that could appear. Now, if I had more than 21, like 24, I would also be guaranteed this. But the minimum number will be 21, which is one more than the solution of this algebra problem here.